Hello everyone, and welcome to the last video regarding special triangles. In this video, we're going to be looking at the 30, 60, 90 triangle, which is also known as the 1 to 2 to radical 3. And as we have discussed before, it's unfortunate that they call it the 1 to 2 to radical 3 because the 90 degrees is corresponding with the 2 and the 60 degrees is corresponding with the root 3. So it's a little goofy. It doesn't work out perfectly, but once you just accept that that's the way it is and you know to look for it, you're in good shape. Okay, so let's take a look at a 30, 60, 90 triangle. Oftentimes they will only mark one of the angles. They'll show that it's a right triangle and then they'll mark one angle, and that's enough for you to figure out that it's a 30, 60, 90 triangle. And let's say in this case that we know that our short side is a 4. So here's how I think is the easiest way to do this. I'm going to write out 1 to 2 to radical 3 because that's the ratio that I want the three sides to be in. And I look at what I'm given, and I'm given that the short side is the 4. So the short side is the one that corresponds with the 1. So that's the 4. The 2 is obviously going to be twice that, which is 8. 4 times 2 is 8. And the root 3, I'm just going to take the 4 and plop on a root 3. So those are the lengths of my sides. 4, 8, and 4 root 3. Please make sure that your double side, your times 2 side, is your hypotenuse. It's the one across from the 90 degree angle. All right, let's do another one just so you can get used to how this works before we start making it harder. So here's our right triangle, and I know that this is 60, let's say, and I know that this side is 10. So again, I would say, all right, I know it's a 30, 60, 90 triangle, so I know it's going to be in the ratio of 1 to 2 to radical 3. This side that I know is the 10, and it is the short side, so it corresponds with 1. I can do 2 times 10, which is 20, and I can do root 3 times 10, which is 10 root 3. So now all I have to do is fill in my numbers. This side, this is the hypotenuse. That's my 2 side. So that gets to be 20. And this gets to be 10 root 3. All right, let's do one more before we move on. Here's your right triangle. That's 30 degrees, and you know that this side is 15. Can you calculate the other 2 sides? Well, I hope you can. I'm going to be quiet and let you do it. Okay, that was long enough. All right, so our sides are in the ratio of 1 to 2 to radical 3. The 15 is our short side, so that goes here. The 2 is 30 because it's twice 15. And the root 3 becomes 15 root 3. So if I were to fill this in, this would be 30, and this would be 15 root 3. All right, let's make it a little bit harder. So one way that we can make it harder is that we can get the long leg instead of the short leg. Let's draw. So here we go, and this time we are given that this is 7 root 3. 7 root 3. So how are we going to calculate this? Well, again, we know that we want 1 to 2 to radical 3. This time we know our radical 3 side, so we know 7 radical 3. that means that we can easily figure out our one side, which is going to be 7. I'm just going to take this number and I'm going to plop off the radical 3. And then our 2 side is going to be 7 times 2, which is 14. So these numbers would be 7 and 14. That's great. All right, let's do one more. Here's this triangle, and we know that this side is 18 root 3. You calculate the other 2 sides. All right, so again, we know it's in the ratio of 1 to 2 to radical 3, and we know our long leg, not the hypotenuse and not the short leg. We know the long leg, and so that is 18 root 3. So then our one side must be just 18, and our 2 side is going to be 36. 18 times 2 equals 36. So this will be 18, this will be 36, and this will be 18 root 3. Okay, that's pretty easy, right? I mean, you kind of got the hang of that. All right, it's got to get even harder. So the hardest way is you get some funky measurements. And the reason that this is harder is because you have to remember a little bit of your algebra, which I know is painful for some of you, but stick with it. You can do it. So here is a nice triangle for you. And it is marked like this. So you know it's a 30, 60, 90 triangle, and you know the length of one side. And you are, of course, asked to calculate the lengths of the other 2 sides. So if this is a 1 to 2 to radical 3 ratio, what side do we know? Well, we know the short side, right? This is the hypotenuse across from the 90 degrees, so we don't have that. Here's the long side, and here's the short side. The short side goes here, root 10. So now it's easy for us to figure out our hypotenuse, which is going to be 2 times root 10, which is easy enough math to do because that just means that you're plopping that root 10 right onto that 2. 2 times root 10. And then this side over here is going to be root 10 times root 3, which, in case you forgot how to do this, is root 30. And root 30 cannot be reduced. So our sides are 2 root 10 for our hypotenuse and root 30 for our other leg. Okay, so that was hard because those are just funky numbers. Let's do another one. Let's do this one. Okay, so in this case, we know our longer leg, and that's all we know. So how are we going to solve this? Well, again, everything is in the relationship of 1 to 2 to radical 3. I'm starting to space mine out a little bit because I'm going to have to do a little math in order to come up with my final answer. The 6 goes with the root 3, right? It's not the short side, which would be a 1, and it's not the hypotenuse, which would be our 2. It's that other side, so it is a 6. All right, so now the 1 is going to be 6 divided by root 3. 6 divided by root 3. Okay, and then remember, we talked about how this is ugly. Mathematicians hate this with radical signs in the denominator. So we are going to rationalize that denominator, and that means that we are going to multiply it by root 3 over root 3, which again is the same thing as multiplying it by 1, right? Because anything over itself is always going to be equal to 1, but it's going to allow us to get that radical sign out of the denominator. So the top becomes 6 times root 3, or 6 root 3. And the bottom becomes root 3 times root 3, or just plain 3. And then we can further reduce it because 6 divided by 3 is 2. So we have 2 root 3 is our answer here. 2 root 3. And so our hypotenuse length is twice that. So that would be 4 root 3. 4 root 3. 4 root 3 and 2 root 3. Those are our sides for that one. All right, let's do one more. I'll get a fresh piece of paper. We will do one more. And we know that our hypotenuse is 29. And we also know that this is 30. So this is a 30, 60, 90 triangle. So can you calculate what those other two sides are? Okay, so the first thing you ask yourself is, what measurement were we given? Well, we were given the hypotenuse, right? The one across from the 90 degrees. So that's this one right here, 29. And then this, our short side, is going to be half of that, which is 29 divided by 2. I'm just going to leave it in fraction form. You could convert it to a decimal if you wanted. That would be fine. But I'm just going to leave it in fraction form. And then over here, this is going to be 29 over 2 times root 3, which, for those of you who are playing along at home, that makes it 29 root 3 over 2. And again, I could get, I don't know what I would get. I would get 14.5 root 3. But I don't really like decimals and radical signs in the same number. So I'm just going to leave it like that. So this is 29 over 2. And this is 29 root 3 over 2. So I guess the moral of this story is, don't be scared by funky numbers. Write out your ratio, plug in what you know, and then calculate the rest and make it look nice. You're doing the exact same thing each time. Just it's harder to visualize in your head because, you know, we don't have a very good concept of what 29 divided by 2 is. We have a much better concept of the number 4. But you're still doing the exact same things that you did when it was easy numbers.